In telecommunications, 5G is the fifth-generation technology standard for cellular networks, which cellular phone companies began deploying worldwide in 2019, and is the successor to 4G technology that provides connectivity to most current mobile phones. Like its predecessors, 5G networks are cellular networks, in which the service area is divided into small geographical areas called cells. All 5G wireless devices in a cell are connected to the internet and the telephone network by radio waves through a base station and antennae in the cell. The new networks have higher download speeds, with a peak speed of 10 gigabits per second, bit/s, when there is only one user in the network. 5G has higher bandwidth to deliver faster speeds than 4G and can connect more devices, improving the quality of internet services in crowded areas. Due to the increased bandwidth, it is expected the 5G networks will increasingly be used as general internet service providers, ISPs, competing with existing ISPs such as cable internet, and also will make possible new applications in Internet of Things, IoT, and machine-to-machine areas. Cell phones with 4G capability alone are not able to use the 5G networks. 5G networks are cellular networks, in which the service area is divided into small geographical areas called cells. All 5G wireless devices in a cell communicate by radio waves with a cellular base station via fixed antennas, over frequencies assigned by the base station. The base stations, termed nodes, are connected to switching centers in the telephone network and routers for internet access by high-bandwidth optical fiber or wireless backhaul connections. As in other cellular networks, a mobile device moving from one cell to another is automatically handed off seamlessly. The industry consortium setting standards for 5G, the third-generation partnership project, 3GPP, defines 5G as any system using 5G NR, 5G New Radio, software, a definition that came into general use by late 2018. Several network operators use millimeter waves called FR2 in 5G terminology, for additional capacity and higher throughputs. Millimeter waves have a shorter range than the lower frequency microwaves, therefore the cells are of a smaller size. Millimeter waves also have more trouble passing through building walls and humans. Millimeter wave antennas are smaller than the large antennas used in previous cellular networks. The increased data rate is achieved partly by using additional higher frequency radio waves in addition to the low and medium band frequencies used in previous cellular networks. For providing a wide range of services, 5G networks can operate in three frequency bands: low, medium, and high. 5G can be implemented in low band, mid band, or high band millimeter wave. Low band 5G uses a similar frequency range to 4G cell phones, 600 to 900 MHz, which can potentially offer higher download speeds than 4G, 5 to 250 megabits per second, bit/s. Low-band cell towers have a range and coverage area similar to 4G towers. Mid-band 5G uses microwaves of 1.7 to 4.7 GHz, allowing speeds of 100 to 900 bit/s, with each cell tower providing service up to several kilometers in radius. This level of service is the most widely deployed, and was deployed in many metropolitan areas in 2020. Some regions are not implementing the low band, making mid-band the minimum service level. High-band 5G uses frequencies of 24 to 47 GHz, near the bottom of the millimeter wave band, although higher frequencies may be used in the future. It often achieves download speeds in the gigabit per second, bit/s, range, comparable to coaxial cable internet service. However, millimeter waves, mmWave or mmW, have a more limited range, requiring many small cells. They can be impeded or blocked by materials in walls or windows or pedestrians. Due to their higher cost, plans are to deploy these cells only in dense urban environments and areas where crowds of people congregate, such as sports stadiums and convention centers. The above speeds are those achieved in actual tests in 2020, and speeds are expected to increase during rollout. The spectrum ranging from 24.25 to 29.5 GHz has been the most licensed and deployed 5G mmWave spectrum range in the world. Rollout of 5G technology has led to debate over its security and relationship with Chinese vendors. It has also been the subject of health concerns and misinformation, including discredited conspiracy theories linking it to the COVID-19 pandemic. The ITUR has defined three main application areas for the enhanced capabilities of 5G. They are enhanced mobile broadband, EMBB, ultra-reliable low-latency communications, URLC, and massive machine-type communications, MMTC. Only EMBB is deployed in 2020, URLC and MMTC are several years away in most locations. Enhanced mobile broadband, EMBB, uses 5G as a progression from 4G LTE mobile broadband services, with faster connections, higher throughput, and more capacity. This will benefit areas of higher traffic such as stadiums, cities, and concert venues. Ultra-reliable low-latency communications, URLC, refers to using the network for mission-critical applications that require uninterrupted and robust data exchange. Short packet data transmission is used to meet both reliability and latency requirements of the wireless communication networks. Massive machine-type communications, MMTC, would be used to connect to a large number of devices. 5G technology will connect some of the 50 billion connected IoT devices. Most will use the less expensive Wi-Fi. Drones, transmitting via 4G or 5G, will aid in disaster recovery efforts, providing real-time data for emergency responders. Most cars will have a 4G or 5G cellular connection for many services. Autonomous cars do not require 5G, as they have to be able to operate where they do not have a network connection. However, most autonomous vehicles also feature teleoperations for mission accomplishment, and these greatly benefit from 5G technology. 5G is capable of delivering significantly faster data rates than 4G, with peak data rates of up to 20 gigabits per second, Gbps. Furthermore, average 5G download speeds have been recorded at 186.3 Mbps in the US by T-Mobile, while South Korea leads globally with average speeds of 432 megabits per second, Mbps. 5G networks are also designed to provide significantly more capacity than 4G networks, with a projected 100-fold increase in network capacity and efficiency. The most widely used form of 5G, sub-6 GHz 5G, midband, is capable of delivering data rates ranging from 10 to 1000 megabits per second, Mbps, with a much greater reach than mmWave bands. C-band, N77/N78, was deployed by various U.S. operators in 2022 in the sub-6 bands, although its deployment by Verizon and AT&T was delayed until early January 2022 due to safety concerns raised by the Federal Aviation Administration. Low-band frequencies, such as N5, offer a greater coverage area for a given cell, but their data rates are lower than those of mid and high bands in the range of 5 to 250 megabits per second, Mbps. In 5G, the ideal air latency is of the order of 8 to 12 milliseconds, i.e., excluding delays due to HARQ retransmissions, handovers, etc. Retransmission latency and backhaul latency to the server must be added to the air latency for correct comparisons. Verizon reported the latency on its 5G early deployment is 30 milliseconds. Edge servers close to the towers can probably reduce latency to between 10 and 15 milliseconds. Latency is much higher during handovers, ranging from 50 to 500 milliseconds depending on the type of handover. Reducing handover interruption time is an ongoing area of research and development. Options include modifying the handover margin, offset, and the time to trigger, TTT. 5G uses adaptive modulation and coding scheme, MCS, to keep the block error rate, BLER, extremely low. Whenever the error rate crosses a very low threshold, the transmitter will switch to a lower MCS, which will be less error prone. This way speed is sacrificed to ensure an almost zero error rate. The range of 5G depends on many factors: transmit power, frequency, and interference. For example, mmWave, e.g. band N258, will have a lower range than midband, e.g., band N78, which will have a lower range than low band, e.g., band N5. Given the marketing hype on what 5G can offer, simulators and drive tests are used by cellular service providers for the precise measurement of 5G performance. Initially, the term was associated with the International Telecommunication Union's IMT 2020 standard, which required a theoretical peak download speed of 20 gigabits per second and 10 gigabits per second upload speed, along with other requirements. Then, the industry standards group 3GPP chose the 5G NR, new radio, standard together with LTE as their proposal for submission to the IMT 2020 standard. 5G NR can include lower frequencies, FR1, below 6 GHz, and higher frequencies, FR2, above 24 GHz. However, the speed and latency in early FR1 deployments, using 5G NR software on 4G hardware, non-standalone, are only slightly better than new 4G systems, estimated at 15 to 50% better. The standard documents are organized by Third Generation Partnership Project, 3GPP, with its system architecture defined in TS 23.501. The Packet Protocol for Mobility Management, establishing connection and moving between base stations, and session management, connecting to networks and network slices, is described in TS 24.501. Specifications of key data structures are found in TS 23.003. IEEE covers several areas of 5G with a core focus in wireline sections between the remote radio head, RRH, and baseband unit, BBU. The 1914.1 standards focus on network architecture and dividing the connection between the RRU and BBU into two key sections. Radio unit, RU, to the distributor unit, DU, being the NGFII, next generation front haul interface, and the DU to the central unit, CU, being the NGFI2 interface, allowing a more diverse and cost-effective network. NGFII and NGFI2 have defined performance values which should be compiled to ensure different traffic types defined by the ITU are capable of being carried. The IEEE 1914.3 standard is creating a new Ethernet frame format capable of carrying IQ data in a much more efficient way depending on the functional split utilized. This is based on the 3GPP definition of functional splits. 5G NR, new radio, is the de facto air interface developed for 5G networks. It is the global standard for 3GPP 5G networks. The study of NR within 3GPP started in 2015, and the first specification was made available by the end of 2017. While the 3GPP standardization process was ongoing, the industry had already begun efforts to implement infrastructure compliant with the draft standard, with the first large-scale commercial launch of 5G NR having occurred in the end of 2018. Since 2019, many operators have deployed 5G NR networks and handset manufacturers have developed 5G NR-enabled handsets. 5Gi is an alternative 5G variant developed in India. It was developed in a joint collaboration between IIT Madras, IIT Hyderabad, (CE), and the Center of Excellence in Wireless Technology, CEWIT. 5Gi is designed to improve 5G coverage in rural and remote areas over varying geographical terrains. 5Gi uses low mobility large cell, LMLC, to extend 5G connectivity and the range of a base station. In April 2022, 5Gi was merged with the global 5G NR standard in the 3GPP Release 17 specifications. Pre-standard implementations. 5GTF, American carrier Verizon used a pre-standard variation of 5G known as 5GTF, Verizon 5G Technical Forum, for fixed wireless access in 2018. The 5G service provided to customers in this standard is incompatible with 5G NR. Verizon has since migrated to 5G NR. 5G SIG, KT Corporation had a pre-standard variation of 5G developed called 5G SIG. This was deployed at the Pyeongchang 2018 Winter Olympics. In the Internet of Things, IoT, 3GPP is going to submit evolution of NB-IoT and EMTC, LTEM, as 5G technologies for the LPWA, low power wide area, use case. Standards are being developed by 3GPP to provide access to end devices via non-terrestrial networks, NTN, i.e. satellite or airborne signal relays to allow for better coverage outside of populated or otherwise hard-to-reach locations. Several manufacturers have announced and released hardware that integrates 5G with satellite networks. Samsung Electronics introduced a standardized 5G NTN modem technology in Korea in February 2023, simulated on their Exynos modem 5300, facilitating smartphone satellite communication. MediaTek launched the world's first commercially available 5G IoT NTN chipset, MT6825, capable of automatic satellite message receipt and extensive power efficiency. Qualcomm, in collaboration with Skylo, announced new satellite IoT solutions on June 22, 2023, including the Qualcomm 212s and 9205s modems, supporting the Qualcomm Aware platform for real-time asset tracking and device management. Motorola's Defy Satellite Link Hotspot, powered by MediaTek's MT6825, became available in June 2023, providing a portable satellite messaging solution with robust battery life and built-in GPS. Rakuten Symphony, in collaboration with Supermicro, announced high-performing Open RAN technologies and storage systems for operators of cloud-based mobile services. In March 2019, the Global Mobile Suppliers Association released the industry's first database tracking worldwide 5G device launches. In it, the GSA identified 23 vendors who have confirmed the availability of forthcoming 5G devices with 33 different devices including regional variants. There were 7 announced 5G device form factors: telephones, times 12 devices, hotspots, times 4, indoor and outdoor customer premises equipment, times 8, modules, times 5, snap-on dongles and adapters, times 2, and USB terminals, times 1. By October 2019, the number of announced 5G devices had risen to 129, across 15 form factors, from 56 vendors. In the 5G IoT chipset arena, as of April 2019 there were 4 commercial 5G modem chipsets and 1 commercial processor/platform, with more launches expected in the near future. On March 4, 2019, the first ever all 5G smartphone Samsung Galaxy S10 5G was released. According to Business Insider, the 5G feature was showcased as more expensive in comparison with the 4G Samsung Galaxy S10e. On March 19, 2020, HMD Global, the current maker of Nokia-branded phones, announced the Nokia 8.3 5G, which it claimed as having a wider range of 5G compatibility than any other phone released to that time. The mid-range model is claimed to support all 5G bands from 600 MHz to 3.8 GHz. Many phone manufacturers support 5G. Apple iPhone 12 and later models support 5G. Google Pixel devices also support 5G, starting with the Pixel 5 and 4 of 5G. Edge computing is delivered by computing servers closer to the ultimate user. It reduces latency, data traffic congestion and can improve service availability. Small cells are low-powered cellular radio access nodes that operate in licensed and unlicensed spectrum that have a range of 10 meters to a few kilometers. Small cells are critical to 5G networks, as 5G's radio waves can't travel long distances, because of 5G's higher frequencies. There are 2 kinds of beamforming, digital and analog. Digital beamforming involves sending the data across multiple streams, layers, while analog beamforming shaping the radio waves to point in a specific direction. The analog BF technique combines the power from elements of the antenna array in such a way that signals at particular angles experience constructive interference, while other signals pointing to other angles experience destructive interference. This improves signal quality in the specific direction, as well as data transfer speeds. 5G uses both digital and analog beamforming to improve the system capacity. One expected benefit of the transition to 5G is the convergence of multiple networking functions to achieve cost, power, and complexity reductions. Radio convergence could result in sharing ranging from the aggregation of cellular and Wi-Fi channels to the use of a single silicon device for multiple radio access technologies. 5G Automotive Association have been promoting the CV2X communication technology that will first be deployed in 4G. It provides for communication between vehicles and infrastructures. A real-time digital twin of the real object such as a turbine engine, aircraft, wind turbines, offshore platform, and pipelines. 5G networks helps in building it due to the latency and throughput to capture near real-time IoT data and support digital twins. Mission-critical push-to-talk, MCPTT, and mission-critical video and data are expected to be furthered in 5G. Fixed wireless connections will offer an alternative to fixed-line broadband, ADSL, VDSL, fiber optic, and DOCSIS connections, in some locations. Sony has tested the possibility of using local 5G networks to replace the SDI cables currently used in broadcast camcorders. The 5G broadcast tests started around 2020, Orkneys, Bavaria, Austria, Central Bohemia, based on FAM-BMS, further evolved multimedia broadcast multicast service. The aim is to serve unlimited number of mobile or fixed devices with video, TV, and audio, radio, streams without these consuming any data flow or even being authenticated in a network. Thank you for watching this video.